Naming acids. When we look at acids, acids are going to have hydrogen as their positive ion. And they can have one or more hydrogen ions found in their compound. When we go to name acids, it's going to depend on whether or not oxygen is present in the particular compound. So we're going to make a flow chart on how to name acids. On the top, we'll put acid. And again, acids have hydrogen as their positive ion. And the first thing we have to do once we determine that a compound is an acid is we have to determine whether or not oxygen is present. So, if there's no oxygen in the compound, we're going to name it using the same prefix and suffix, and we're just going to alter what the stem is. The prefix is hydro for all acids that do not contain oxygen. The suffix is ic, and then we'll put acid at the end. Again, the thing that will vary is what the stem in here is, and that's dependent on what the anion is in the acid. If we have HCl, we know that it's an acid because it has hydrogen as its positive ion. It doesn't contain oxygen in its formula, so we're going to follow this arm of our flow chart. Our prefix is hydro. Our stem is going to be chlor because chlorine is the negative ion. And then our suffix will be ic, acid. So hydrochloric acid is HCl. If we had H2S, again, it's an acid because it has hydrogen as its positive ion. There's no oxygen in the formula, so we follow the left-hand arm of our flow chart. Hydrosulfuric acid would be our name. Now let's say we have hydrofluoric acid as the name, and we want to write the formula. Since it's an acid, hydrogen is the positive ion, and since it has the prefix hydro in it, it doesn't contain oxygen, our negative ion is going to be fluoride. Hydrogen is a +1 charge, fluoride is a -1 charge, so our formula would be HF. Now the other side of our flow chart would be if we have an acid that contains oxygen. And the important thing about naming these is that there is no hydro in the name. And everybody wants to write hydro in the name for an acid because hydrogen's the positive ion. But the prefix hydro tells us we're looking at an acid that doesn't contain oxygen. So acids that contain oxygen have no hydro. Their negative ion is going to be a polyatomic ion. And the suffix we're going to use for these acids depends on what the suffix in the polyatomic ion is. So we're going to make a little table here. We'll have ion, and we'll have acid. And again, we're going to need to know what our polyatomic ions are. If our ion ends in ATE, then in the acid name, that ATE is going to be replaced with ic. If the ion in that acid ends in ITE, we're going to replace that ITE with OUS. So if we had H2SO4 and we wanted to name this acid, it has hydrogen in it, so we know it's an acid. It contains oxygen, so we're going to be on the right side of our flow chart. We're not going to write hydro as a prefix. We have to think about what SO4 is. And knowing our polyatomic ions, we know that SO4 is sulfate. 8 will be replaced with ic, so this would be sulfuric acid. Or if we had HNO2, the H makes it an acid. It contains oxygen, so we're on the right side of our flowchart. We're not going to use the prefix hydro. NO2 we should recognize as being nitrite. Ite goes to us, so this would be nitrous acid. So let's look at some examples. Let's say we've got HF. It's an acid. It doesn't contain oxygen, so we'll go along the left side of our flowchart. We'll use our prefix hydro. Our stem will be fluor, and our suffix will be ic. So hydrofluoric acid. HCl. Again, it's got hydrogen as its positive ion, so it's an acid. It doesn't contain oxygen, so we're on the left side of our flowchart. Our stem will be chlor, so hydrochloric acid. HNO3. It's got hydrogen as its positive ion, so it's an acid. It contains oxygen, so we're going to be on the right side of our flowchart. NO3 is nitrate. 8 is replaced with ic, so our name would be nitric acid. H2SO4. Hydrogen as its positive ion makes it an acid. Has oxygen, so we're on the right side of our flowchart. SO4 is sulfate. 8 gets replaced with ic, so sulfuric acid. So let's go from names to formulas. Acetic acid. The acid part tells us it's got hydrogen as its positive ion. There's no hydro, so we're looking at a polyatomic ion for the negative ion. Ic goes to 8, so we need acetate. Acetate is C2H3O2. Hydrogen is a +1. Acetate is a -1. So our formula would be HC2H3O2. Hydrocyanic acid. The hydro, or the acid, tells us it's got hydrogen in it. The hydro tells us there's no oxygen in the formula. Cyan is cyanide, which is CN. We've got a +1 and a -1. We'll crisscross those just like we did with other compounds that contained polyatomic ions, and we get HCN. Hydrosulfuric acid. Acid tells us there's hydrogen as our positive ion. Hydro tells us there's no oxygen in the negative ion. And the stem tells us that the negative ion is sulfur. Sulfur becomes a sulfide ion with a -2 charge. We're going to take the 1 from the hydrogen and the 2 from the sulfide, and we're going to get H2S. Nitrous acid. Hydrogen as a positive ion. No hydro, so we've got oxygen as our negative ion. Us goes to ite, so we need nitrite, which is NO2. Hydrogen is a +1. Nitrite is a -1. We're going to crisscross those ones, and HNO2 would be nitrous acid.